Hello guys, today we will be working on this door which can open and close, and we can also interrupt this door from opening and closing just like that. We can stop it midway. I can catch it just like this. We have controls over the starting position, so here we will set it to open and set the starting angle to say 35. You can see it opens, starts open, and it can open to 90, then close. We can also restrict the opening to the starting angle, so from here it will just close and stop at 35. If we untick that, we can also change the opening angle to say 70, and we can also change the door speed, so let's make it 2 times faster, from 35, 75, close, to 75 again, and you can see that the door has gone 2 times faster. So we also have this flip variable. When we tick it, it will start on the other side, and it will also work on this side now, so the door opens inwards here. And so we also have this closing angle, so if we set it to 20, we'll start at 45, go to 90, but it won't close past 20 degrees here. So yeah, this door has pretty cool settings, and today we will learn how to make it. So in the previous tutorials, we've set up a interact dot, and we also have a line trace, which currently does not do anything when it hits this door. So we'll set that up today, and if you haven't seen the previous tutorials, I'll leave a link to them in the description. And if you don't want to watch those videos because they are a bit long, I will make another shorter video covering a basic interaction system so you can get started and continue on with this video. So if you have the interaction system already but don't have the door set up, and you don't have the starter content, you can go to this add button here, add feature content pack, go to content and add the starter content, add to project. So what you want is to duplicate the PP base item. Make sure you create a child blueprint so it inherits the functions of the base item. Call it PP door 2 because I already have one. And in here, change the base mesh. Go over to the static mesh and search for door frame. Use the SM door frame here. Next, we want to add the door itself, so we need to add another static mesh. Call that door mesh. And you can change the static mesh to SM door. This one, and it will be off-centered compared to the frame. So what we want to do is just move it. Let's change the snapping. Just center it against the door frame like so. And then next we want to add a collision box here, a box collision. This will be the interact area. Parent that to the door mesh and set it to where you'd like the interaction dot to appear. Let's just put it around here. Select the base mesh here and search for tag and get rid of this. This is so we don't have the interaction on the frame itself. Make sure door mesh is cleared as well. And for the interact area, let's add the tag. Interact. Make sure it's spelled correctly. And then in the interact area, search for collision. Make sure you change this to custom. And depending on how your line trace is working, right now we have it on visibility. We want it to block here, and let's drag that into the scene. And then we need to change some of the information on this item. So under here we should have ST item. If you don't have it, you can go up to this setting cog here and show inherited variables, have that ticked. So in here, the default values, change the interact type to use, interact name, set it to door. And this ST item is only available if you followed my previous tutorials. And actually one more thing I'd like to mention. This door mesh may not have a collision. So if you select this and head over to the static mesh, you can find it in its folder. Double click that. Then you can check the collision here by going to show, simple collision. And if it does not have this green box around it, for example, it looks like this, you can see here we can walk through the door because there is no collision. By default, sometimes it's off, so you want to head over to this collision and just add a Z simple collision here. And there you go, we can continue from here. And before we start adding functions to the door, I want to change the interaction system a little bit. So in BPI Interact, under Get Item Info, let's add a new output of type Boolean, and let's call it can interact ? Compile that. So let's go to the BP base item now, and in the interface tab, Get Item Info, we have this new variable, and we'll create its own variable, name it the same, and interact ? And turn on instance editable, expose on spawn, and simply connect that to the return node here. And let's compile that. The BP third person, so we can press Ctrl P to bring up this search menu. BP third person. Under the interact dot function, let's make some space here. So just before we set the interact reference, we will get the hit actor, and we will get that interface function here, get item info, and let's connect that here. And we will add a branch node now and connect that to the condition. So if can interact is true, let's set it. If false, let's just clear the interaction reference. Let me just clean this up a little bit here. Just like that. And compile that. And let's actually set the can interact to the default under BP base item. Let's set it to true as a default value. So let's duplicate this door, and we'll say the left one you cannot interact with. And as we walk up here, we get the interact dot, and the left one does not have the ability to interact. So now we can start adding functions when we press a keyboard to interact with the door. So back in BP third person in the event graph, in the previous tutorials we had this E keyboard press that fires a line trace and also this left mouse function. We don't need these for now, so delete them. Instead, we will be using the enhanced input system, which gives us more functions when we press a key and also allow us to change keyboard bindings during gameplay. So in the content folder, third person, input actions, let's right click and create a new input action here. Let's name it IA interact. So inside here, let's add a new trigger, and let's use pressed and save that. Head back to the input folder, IMC default, and let's add our mapping here. So add a new mapping, select IA interact, press this keyboard icon, and let's use the letter E on our keyboard. So press E, and let's save that. So back in BP third person now, we can right click and search IA interact, and this one here. And instead of firing a line trace, since we've already set the interact reference here in the interact dot function, we can get that reference now. And let's convert that to a validate get, connect that to started. So if it is set, we can use that interact function from the BPI interact and connect the reference here to the target. So let's just test that the interaction works by heading over to BP door, and in the interface tab, interact, double click that, and we get this event. And let's just destroy the actor for now. Compile that. And as we see here, when we press play and press E on the door, it should disappear. Okay, so let's start opening and closing the door now. So in BP door, right click, add a custom event. And let's call it door event. And we need a timeline node here. So right click, add timeline. Let's call it open/close timeline. And let's connect that to play from start. So double click the timeline, and inside here, let's add a new float track. Let's just call it alpha and set the length to 1, and that will be how much time the door opens and closes. And in the graph here, let's right click, add a new key, set the time and value to 0. And we need another key, and this time set it to 1, and the value set it to 1 as well. And so as the time goes up, the value of alpha will increase. And I forgot to mention this at the time of recording. Click on the graph here, press F, you can frame the whole curve here. Highlight these 2 points, right click on a point and change it to auto. So the door will accelerate slowly, keep a constant speed, and then decelerate as it reaches its open position. And we will use this alpha value with a lerp node, lerp float here. Let's connect that alpha value. And so when the alpha goes from 0, it will be A, and as it goes up to 1, it will be B. And let's set B to 90, because we can see here, when we select the door and rotate it on the Z axis, we get 90 here. And so that will be the open position. And before we continue, make sure this interact area is attached to the door. So let's reset the rotation. Let's drag this into the door mesh to parent it. And now the interaction area follows the door. So from the timeline now, in the update, let's rotate the door. So set relative rotation door mesh here. And we get this rotation value. And we only need the Z axis, so right click on it, split structure pin, and connect the return value to the Z axis. And in the event interact, let's get rid of destroy actor, and let's use our new door event here. So when we press E, it should play this timeline and open our door. So let's test that out. Press E, and we can open the door. But if we press E again, it will just replay it from that starting position. And so we need to fix that. So just before timeline, we will drop a flip-flop node here. Let's connect that. So if it's A, it will play. And if it's B, it will just do a reverse. So let's test that out. Press E, opens, and then we can close it. And we can also open and close it midway, just like so. For better control over the door, we want to know the state each time it opens and closes. So let's add a new variable. Let's call it isClosed. And compile that and make sure the default value is set to true. And from the finished in the timeline, let's set the isClosed variable here. And what we want is to reverse the value, so drag off and get the isClosed variable and add a not boolean here. Connect that into the set. And let's drop a print string node here and connect that to the in string and the execution pin. And let's test that out. So when we open the door, isClosed variable is false, and when it's closed, we get true. Let's head to the construction script now, and in here we want to set the starting position of the door. And we have 3 states of the door, so one will be open, the next will be closed, and the third one will be locked. And so we can actually create a enum for this. First, let's actually create a new folder here in the interact folder. We'll just call it doors, and let's drag BP door into here. And inside here, we can create the enum. So search enumeration. Let's call it E door states. And let's double click that. And again, these are just a collection of names. So we will input 3 of them. The first one will be, we'll just say closed. The next one is open. And the third one is locked. Just like so. and save that. Let's add that variable in BP door. So add variable, we'll call it door states and search for E door states here and compile that. Default value is closed. Make sure instance editable is on and expose on spawn. Compile that. So from door states, let's drag that in here. And we want a switch on E door states. Connect that in. And so when the door state is closed, we want to set the isClosed variable to true. And then let's copy paste that below. And if it's open, we will untick this one. From open, we want to set the relative rotation of the door mesh here. So we right click new rotation, split structure pin, and we want the Z axis. So we can put 90. We can also promote this to a variable. And let's call this new variable open angle. Let us make this instance editable, expose and spawn, compile and make sure the default value is 90. So in here, we have this new drop down menu of door states. We can set it to open and we can also change the starting angle here. So when we press play, the door is open, but we have this problem now. When you press E, it will close again. So we will fix that. And that's because here in the timeline, it always starts at 0. So even though it's open, say at 45, it will quickly jump to 0 and then go to 90. So for example, if we take the open angle and plug that into A, that will solve our problem here. So press E, it will open from that angle. But when we close it, it will stop at that open angle. So what we want is when it starts open, we choose this open angle as A, but for all other times, we want it to be 0. So what we can do is add a new variable, and let's call it start open question mark. Compile that, and in the construction script, let's add that in here. We'll set it to true. Plug that in there. And here, let's make some space. What we want is to duplicate the lerp value here. Let's just drag this a bit down and make sure you connect the alpha to the second lerp. And from here, we want a select float. Connect the return value to the Z axis here, and the second lerp will be here. And for the pick A, we want the start open here. So when it starts open, it will use the open angle. If not, it will be 0. And so we only want this to happen one time. So from finished, we can drop a sequence node here and hold down O and left click for a do once node. Connect that to then 0. And let's set the start open to false, so unticked. And then 1 continues down here. And so, yeah, let's test that out. So it's slightly open. When you press E, opens and closes. And if you do want to limit the door to the starting angle, we can do that as well. So back in the construction script, we need to first duplicate the open angle and rename the original open angle to starting angle. And we'll just rename the duplicate to open angle here. And make sure the open angle has instance editable, expose and spawn. But we will set the default value to open angle as 90 here. And we need a new boolean. Let's call it restrict angle question mark. Add a branch node here, and let's connect the new boolean there. So restrict angle into the condition. So if that is true, you want the open angle to set it to the starting angle, just like this. Let's just organize this value here. Yep. And make sure restrict angle is instance editable, expose on spawn. So in the event graph, we can take the open angle and let's connect that to the p-values of both these two lerps here. So in between the flip-flop node and the timeline, let's make some space here, and let's take our restrict angle and our start open boolean. Let's connect that with a AND boolean. Let's drop a branch node here, connect that to the condition, and we will highlight them and collapse them to a macro. Let's call it check restrict angle, and double click that and make sure the branch is connected to the input. Let's take the true and the false and connect them to the output. And the reason we did that is because we will be using them twice here. So just copy paste them. And so if the door is open and we want to restrict the angle, we want to close the door. So instead of pressing play here, which will open the door, we want to loop back, go around and do the B in this flip-flop, which should close the door. And let's just double click these lines to add some reroute nodes. But if it's false, let's just play as if it were normal. So in here, it'll do just another double check. And we want to invalidate start open. Otherwise, we'd have to wait till it's finished before you can untick this and choose these values. So let's take our start open. Let's leave that unticked. Connect that to the true. And if we press E again, we want to open the door. So we want to go to the false here. So we also need to invalidate the restrict angle as well. And because we are going around this way, we haven't played the timeline yet. So we want to reverse from end. And if none of these are true, we press E again, we will just reverse it as normal and it should close the door. So let's test that out. Walk up to the door, closes, opens, and stops at that restricted angle there. And if we leave that unticked as well, and say we want to change the different open angle, so it can start at, we'll say 25. So when we walk up, it will open only to 60, close, and go back to 60. Actually, there is one more problem here. Setting this to 90. And if you press E before it opens, it will go back and stop at the starting angle. So we will fix that. And the reason for that is because when it plays, it goes to the open angle and goes back to the starting angle because of this variable here, starting open variable. When interrupted, it doesn't go through this finished execution and untick this. So while this stays true, we are stuck looping back between these two values. So we can simply disable the interaction. So we will disable it here at the start. So connect the branch node, get the start open variable, connect that here. And so if this is true, we will set can interact to false, and we will continue to open the door. And if start open is false, we will continue as normal. So during this time, we cannot interact with it until it is finished. And so we can set can interact here now to true. Connect that there. And let's test this one out. So now when we walk up to the door and interact with it, we won't be able to close it or interrupt it until it's fully open. And when we close it, it does not get stuck at that starting angle. And now we can also interrupt it before it opens. So before we continue, let's just clean up the graph a little bit. So over here where we set the rotation, let's first add a reroute node here for the alpha. Connect these two alphas together. And with that selected, select these nodes, right click, collapse to macro, and let's name it set door rotation. And let's just change this input name to alpha, just like that. And in the finished, we can take everything here. We can get rid of this print string for now, highlight them, collapse that to a macro as well, and call it finish open / close. Now let's take all these ones here and make sure we add a reroute node here first. So select these branch checks, right click and collapse it to macro, and we'll call it door check. And let's untangle these now. So we will bring output pin 2 up here, and I think reverse this one. Let's call it play reverse, and then reverse end, just like that. And let's highlight everything, press C on our keyboard to add this border around it, call it door event, and let's just give it a good color here. I actually want to add a way to control the speed of the door opening and closing. In the variables tab, let's grab the open and close timeline, and that is a reference to this. And let's set play rate here, like that here. And in the new rate, let's promote that to variable. Let's call it door speed, and let's set the default value after we compile to 1. Make that instance editable and expose on spawn. And let's just bring this variable just below the open angle here. And so we get this new variable, door speed, with the second door selected. Let's change it to 4. Make sure can interact is on. And so this one with a speed of 1, quite slow compared to this one, which is super fast now. So one last thing we can add is the ability to open the door on the other side. So it will open inwards this time. So back in the construction script, let's make a new variable. Let's call it flip ? And let's make sure instance editable is on, expose on spawn. Compile that. So let's drag this new variable into here. Let's take the starting angle and go multiply, and we want to multiply it by -1, so the angle goes the opposite way. And we can get a select node here and plug this flip variable into the index. And so if flip is true, we want to multiply the angle here, we plug that into true. And if it's false, we just use the normal angle. And let's double click this float line here, and let's connect this two together. So we want to select these, right click and collapse it to a macro, and we'll call it flip values. Double click in here and make sure the return value is in the outputs here. And in the construction script, make sure you take the end of this macro and connect it to the set relative rotation. So let's go to the event graph under set door rotation, and here in using these two values, let's use the macro here. We need it twice, so copy paste that. Starting angle, let's use this macro here, and the first lerp into A. And the open angle, we can shift click and put that into this macro and connect that to the input. Compile that and test it out. Now we can set the starting angle by using this flip button, and our values are now corrected. It will open and close inwards like this. So one mistake I've noticed is that when the door starts open and we open it, it prints true at the top left, and if we close it, it prints false. And that is because here in our finish open close variable, we are just flipping this is closed variable regardless of the door position. So what we can do is delete these for now, and instead we can actually add a new variable. Let's just duplicate the open angle. Let's call it close angle. And make sure instance editable is on, expose and spawn. Compile that, and let's set the default value of close angle to 0. Let's just drag that just below the open angle variable here. And so let's take this open angle. And so if this is equal to the door mesh, we'll grab the door mesh. Let's get the relative rotation here. We need the z-axis, so split this and connect the z-axis. And connect the z-axis here. When the z rotation of the door mesh is the same as the close angle, when this timeline has finished, we can say that it is closed. So connect that here. And we can also head back to the event graph in the set door rotation. We can also take this close angle now. And make sure you use the same flip values here. Connect that here. And before we connect this value into this lerp, I've noticed we don't need two lerp nodes anymore. Let's take this select float here. Let's paste that here. Let's connect that to the B value. Let's take the starting angle, connect that here to A. And let's take the open angle with this lerp here. Paste it down here. So from this select float, we will put that to the A in lerp. And we can delete this now. Connect the alpha down here. Take the return value, put it back to the set relative rotation. It just makes this part a lot neater. And one thing I forgot, in the finish open close macro, where we set the is closed variable, we need a flip values. So in case we have the variable flip on, you want to compare two negative values here. And so when we open this door, it will print false, meaning it's open. And the close angle is printing true because it's the same angle as the door position. And we can also restrict the closing angle. We'll go to 90, print false, and you can drop down to 20 and print true, and we cannot actually get to 0. We've restricted the closing angle. Okay, I think I'm done now with this door, and we have a bunch of settings here that we can use. In the next part, I will add the ability to unlock this with a key. So hopefully I see you there. And thank you for watching. Bye.